Assalamualaikum and good afternoon. So today we will see a few questions regarding to centrifugal pump. So we go for question number 5. To determine the torque and power output for the turbo machine shown below, this is the data of the pump. Outer radius 300 millimeters, inner radius 150 millimeters, flow rate 0.057 meter cube per second, speed 25 radian per second, and density is 1000 kilogram per meter cube. So here, this is the turbo machine, means the pump, because we could see here the inlet flow is from I, the center point here, go through like this, and then this is the outlet. This is the output. So and then it gives you V1 is equal 3 meter per second and V2 is 6 meter per second. So normally if question give you something like this, it will show you the actual velocity. Okay, so this is the okay. So and then we have all of these parameters. So here one of the important things that you should know is the speed show here is in radian per second, because in previous tutorial I always give you in term of RPM or rotation per minute. So M here is for minutes. So means that you need to really understand the meaning, and please use the suitable equation. So 1000 kilogram per meter cube. So this is the density for water. So I think you already know this. Okay, so we will answer this question. So the question is about the torque and about the power output here. So for the diagram here, so we know that the V1 is equal to 3 meter per second. So, and then the V2 is equal 6 meter per second. So as I said, if the actual velocity goes straight like this, so we could assume that maybe the world velocity is neglected. So we could draw our velocity triangle like this one. So and then in the outlet, so this is the outlet velocity, the actual velocity at outlet. So we could draw the velocity triangle like this one. So means please, I hope you could draw the velocity triangle very well. And then you could determine the blade angle here, or according to this one, I'm sorry, okay, this is not the blade angle, this is the angle where the outlet velocity flows out. So this is the angle. So means that I hope you could draw the angle very well here. So and then after you draw the velocity triangle, so what need you to do is, okay, first question is about the torque, and then you could refer to our lecture notes. So it is found that the torque here, the T, is equal to rho Q V1 2 R2 minus V1 R1. And then we could simplify it because the value of V1 here is equal to 0. So means that the equation here is become like this. So and then everything means, again, I remind you here, the only two parameter that you could calculate using fixed equation. So mean there is the U and also the idea of VF. So U here is equal to R omega and equal to pi dn over 60. However, in this question, because the question give you RPS, rotation per second, so means that you need to use pi dns, because no need for you to divide with 60 here, because why we need to divide by 60 here, because the unit for n here is in minutes, RPM. Okay, if you are using RPS, rotation per second, so mean please do not divide it with 60. So and then the VF here is you could calculate by using normal continuity equation. Q equal to AV and V is equal to Q divided by A. and the official equation will become K pi dB. Okay, that is the equation. Okay, so and then more than this, other than this, so means that you need to define your own equation from the velocity triangle. So in previous set of tutorial, we usually supply, or we solve tutorial problem by using the blade angle. But now, okay, we have an angle, but that angle is actually showing the angle of outlet velocity here. So means that you use this 30 degree, so it is equal to this side, this angle, and then you could define that the V2 here can be calculated as V2 cos 30, so you could get it 5.196 meter per second, and then you could calculate the value of torque here, so it is equal to 88.85 Newton meter. So and then we go for power. So this is the basic equation for power, rho GQH, but we must very selective in terms of H, because in our study here, we will have manometric head and also Euler head. So because in this question, the question is very simple, and the we don't have any information about the efficiency, so we just assume that manometric head may be equal to Euler head because there are no losses. So then we could calculate the value of Euler head here by using this equation. Okay, so and then again, we need to determine what is U2 and what is V2. And according to the previous calculation, we know the value of V2 here. So we could use this, and then we could calculate the value of U2 by using the idea of this one. Okay, so because we have so many equations, we have R omega, R2 omega, or pi ds over, or pi dn over 60. So means that I hope you could remember all these equations. So we use this equation because it is already given by radian per second. So we use the radian per second, so we could get it is equal to 7.5 meter per second. So and then we could calculate the value, the amount of Euler head, which is 3.9725 meter. So then we could calculate the power here as 2.22 kilowatt. Okay, please bear in mind, if you answering in test 2 and final exam, please make sure that you calculate until 3 or 4 decimal point, because the more accurate you could give us, the easier you could get more marks. So this is because if you just round up everything, so your final answer will slightly will have big difference from our scheme. Okay, from our schema. So that's a little bit dangerous for you, because we always find the accurate answer for final and also for test 2. So this is the idea to calculate the power in this question.